Okay guys, I thought I would do a series on these 361 kit saws from Holzfforma. I think, well, obviously they have a fairly big following online. A lot of people like them. They port out really good and make really good gains, at least the stock steel OEM cylinders. But I figured it would be good to show kind of a modification series of step by step what each modification does, because there are a lot of people that whether it's on the forums, YouTube, wherever, there's all sorts of information on the mods, whether it's a muffler mod, gasket delete, full port job. But a lot of people ask the questions, well, what can I get with just a muffler delete? I mean, a muffler mod and a gasket delete. You know, for people who maybe don't have the tools, they're curious to know, well, what kind of gains can be seen with a good muffler port job, right? Muffler mod, and possibly a gasket delete, maybe advanced ignition timing, those sorts of things that people can probably do with, you know, just a drill and a hand file and stuff. All that being said, you do need some special tools to be able to mod one of these mufflers. 361 muffler is terrible, and to really gut it properly, you have to cut the perimeter crimp to be able to split, to be able to get out that lovely baffle there, what we're seeing it. Right, so this takes a little more. I use my belt sander for this, but yeah, I think people are generally would be interested in seeing a step-by-step series from dead stock right up through all the different steps to get to fully ported, with then further steps to do a dual port muffler, not just a single port, dual port, to see if it makes a difference. And then from there we can look at intake side, which would be modding the carb, probably opening the venturi just a little bit, you know, grind maybe half a millimeter on the radius, or maybe a full millimeter diameter increase on the venturi, on the bore, while trying to maintain the venturi effect. You know, you don't want to create any flat spots to create eddies. You got to try to blend it and make sure that it still functions properly. And then ultimately that series of this would all be with a standard bore, 47 millimeter. But what I want to do, I've already built one of these 361 kits with the big bore cylinder. So what I would like to do is to just build up this one, make a series of it, stock 47 millimeter bore, and then compare it against the big bore, both ported, just to see if it's worth the squeeze on buying the big bore cylinder, or whether you can actually get, you know, comparable performance with the stock bore. I know a lot of people, there's a lot of theories between reasons why the stock bore works better, because it's a tighter, less case volume, it's a tighter cylinder, and it just works better. I don't know, maybe that's with the stock cylinders. Obviously these are Chinese cloned cylinders, so they're not the greatest. There's a lot of stuff. I mean, you got to open these lures significantly to get good flow, and you know, the timing numbers aren't too terrible, but ports need, there is a lot of grinding to do. But that's where the build series ultimately is going to end up. Building the stock 47 millimeter bore, max it out to where we think we can get it with the stock 361 carb, and not the people swap carbs and modify like a 390 carb or a 440. This is 361, 440. I mean, it's a huge difference in size. But I'm thinking that we will try to mod the stock carb and see what we can get out of it, get the most out of this, so we're not throwing away parts from the kit, you know. I'm all about making the max power and trying to get the best out of it, but I don't want to, for the stock bore at least, I want to see if we can get away with just the stock carb with the big bore, seeing that it's a bigger air pump, you want more flow for sure. So I think that the stock carb will limit the big bore. And I'll probably swap shafts and do a I've never done it before, but I've seen it done, so we can mod the carb and see if we can put a 440 carb on the big bore. Right, so I think it'll be a fun build series. For right now, stage one in this is completing this build. I do need to check timing numbers, and I also want to do check not only timing, not only port timing, but ignition timing as well. So if I can find the pin. Oh, another thing that I should mention, which many of you building these kits may or may not. If you build more than one, you will probably find that their tolerances on many of these pistons, they're different manufacturers that supply these parts for the kits. So for example, this piston and cylinder is the stock bore off of the first kit I made that has on the big bore. And if you compare two pistons, skirt length is the same. You can tell they're different manufacturers because they have different arrow marks. But what is noticeably different is the first kit. The first piston has a huge relief. That's about 5 millimeters or so. It's reliefed right down so it doesn't hit the crank, the lobes on the crank. This works fine. This one, the second kit, I've already ground this out to relieve that. I have to do some more grinding because it's still barely touching. But that is the difference in the kind of components that you may get, right? Everything else spec wise is pretty much the same, but you've got to check the clearancing on it. You know, we're going to mod the piston for sure. We're going to lighten it. These 361s, the cylinder is pretty much bottom fed, so in theory opening the ports and reducing material on the piston is increasing case volume. But for me, the benefit of a lighter cylinder, a lighter piston, I just want that response. I want as light a piston as I can get. So I am going to still open windows, lighten it up a bit, grind on the inside. What I'm going to do is I'm going to take about 1.5 millimeters off the bottom of these skirts here. I don't know if you can see. I have a line scribed there. That is the line of the exhaust. So she definitely will not free port. That's the bottom of the exhaust there with black Sharpie. So tons of room, no free port issues. So I'm going to remove that, probably get 1 gram or 1.5 grams or 2 grams out of that maybe, right? So we're going to lighten up. But those are the differences between pistons and you know, that's the problem with these, with Farmer Tech. Generally I found them to be decent, but they are sourcing all of these parts from manufacturers all over China, and you're going to get differences, you know, from batch to batch. So you definitely have to be someone who can tinker and grind and cut and make sure things fit. Right, so yeah, that's that. I think what we'll do now is just time the cylinder. I will. We're pretty clear here. Let's just get this. Here. Don't have any clips in here yet, so we're just. What I'm going to do, I'll time it with the gasket because I want this to be a completely stock build, from as if you bought it, either built it and used all the stock components including the gasket, or whether you bought the G366 from Amazon or off of the US Holzfforma site, right? I presume that is this is what you would get. So let's try and get this. Come on. Right. So let's get this in here. Space is a bit tight. Not ideal, but it is what we got. So let's just get these started. Just give them a little left tap with the impact. We should really swap out to a drill. I could actually use this drill. You know, the drills that have the clutches that you can set your slip torque. But I just give it these just run faster, and I don't strip threads or anything. You don't overdo it. I always do final tightening with by hand. But I just go until you barely hear a little tut, and then you know it's good to go. At least it's bottomed, and then you can hand tighten. Alright. Piston stop. If you want to be accurate, you gotta use it. I know a lot of people use like these. And you can do it. You can do it whichever which way you want. Before I got piston stops, I would use anything hard, like a piece of the stuff that comes in the kits to wedge it off. The problem with these is, depending on the exact location you get on, if you're on the squish band on a certain area and you slip slightly, it may change the timing, and it's not really repetitive. This steel screws in, absolutely repetitive. So if you really want to do it good, and you just be confident, buy one of these steel piston stops. Alright, so I believe I had this zeroed before. That's reading 58 before top dead center. This is 56.5. So we gotta go like 3/4 of a degree. Let's try that. Let's do 50. 57. 57. That's it. Well, just to show you, I don't know if I can get you low enough. That's pretty much 57 there. You got to read the same, right? So that's it there, 57. Pretty much 57. So we know we're centered. So we are centered. What I'm going to do, I just bought this guy. You know, Dyno Joe likes to use a digital gauge, and a lot of people favor it. I mean, this is this takes batteries. This doesn't die. This will die on you. But for convenience and workspace, like right now, this blocks the entire. It blocks the entire engine, right? Especially when you're putting down sealant on gaskets or you're trying to work on it, and you know this is kind of in the way. If you ever want to pull a cylinder, mark it, put it back, and this on a chuck takes up zero space. You know, it's just out of the way. You can see everything much better. So I think I might do a vid comparing using a just traditional timing reel and then using this as well, which is cool. I think I'm going to transition to using the digital just for convenience. But anyway, we are centered there. Alright, so let's go TDC. Well, first let's check squish. This is 50 thou solder. I don't know if this is going to be thick enough. This may not read. This is going to be way, probably like 40 thou. .44 thou. 40.5, yeah. Again. These gaskets are usually about 20 thou, 19 or 20, so we should be spot on with a gasket delete, but we're going to run it stock first. I don't even think we near weren't even touching there. Yep, 40.5. Doesn't seem right. I'm gonna double it. Twist it up. Yeah, 41.5. So, squish is terrible. But the timing numbers, if we check, intake is over there, 70. There's a little divot at the bottom of this intake. Over there. Yeah, nearly 71, 70 and a half. Exhaust. If I use light first. That's ray of light. 102. If I go visual from top of port, say 104. When And there are a lot of different ways that people time. I mean, it's you know, ray of light, and they stick something in it like a feeder gauge, and stick, you know, have a positive stop. Most people just time by light, though. I mean, you know, but you can be off by a good few degrees if it, depending on how you do it. Yeah, 102. Transfers are, luckily we can peek through the decomp hole. And old guys over 40 need the specs. So from the top, it looks to me like the hold on. The transfers towards the intake. I call them secondary. They don't have that secondaries. They fire first. They are at 124. Let me go through. I can probably see a bit better. Straight across the top of the piston. And 123. And 125. I usually put these numbers in my phone. Let's just write it down here quick. So intake between 70 and 71. Exhaust around 102. Trans 123 and 125. Just about. When I port this, we'll probably raise, we'll probably not going to stagger the transfers, probably raise them slightly and keep them same, time the same. What else do we have to say about these? We are going to, so my idea for this build is to pretty much do it as a step-by-step for progression from dead stop basically right up to fully ported. Start with it as you get it from factory as a G366 or built from the kit, which once we finalize this build, we will tune it, get it dialed in, go and do some test cuts, dead stop. Then the next step will be to do the muffler mod, which of course these cans are seriously restricted. I mean, people even get gains by just drilling a couple holes and freeing it up, and these really respond well to just a muffler mod. But we're gonna split it, completely gut it, and open up just this portion here. Let me get back behind so I can see what we're doing. Right, so all of this is going to get opened up pretty much to about where my fingernail is here, like massive, as big as we can, single port, right? You don't have to worry about exhaust gases shooting straight out because of this. Basically anything coming straight out here gets guided and redirected by the gases being redirected by this, right? So this pushes everything forward. So you know, when you open this big, even if it's up to here, instead of shooting out forward, it kind of shoots out at a 45. So you still miss your your brake cover, and you don't have to worry about it too much. It shoots off somewhere like in this direction. Right, comes straight up through here, so you don't have to worry about it touching the brake. So we're gonna do muffler mod first. Do timed cuts, 3 cuts in a uniform piece of wood. You know, if I was Dino Joe, well, we would have graphs to look at and see what every mod does in terms of where it drops off in torque, where it gains, you know, what your peaks are. But I gotta use a wood dyno, so I would rather, to try to be as accurate as possible, comparing times at least, I want to cut a square cant out of the biggest piece of wood something reasonable, like 16-inch square, 14-inch square, something that's not going to be just a 5-second cut. You know, it's got to be, I want it to be like plus 10 seconds that you can definitely see the difference. So I need to hunt down for some wood, mill a cant out of it, and at least we have a consistent cross section and type of wood that we can compare every mod going forward, right? So muffler mod, 3 cuts, take an average, then do the gasket delete, 3 cuts, take an average, of course tuning in between everything. Next will be possibly timing advance as a step 3, or I may do the timing advance after all the port work and do that as like a final thing. Not sure yet, but timing is definitely going to come into it. We are going to then do the port work, put that back on, retune, 3 timed cuts, take the average. Then what I would like to do is confirm whether or not we can get better flow. Instead of, we'll move to a double port muffler. As I said, this will be a big single port, but we'll probably put another outlet here and weld on a deflector, or put a piece of pipe right here at an angle, right? So one or the other, but it will be a higher flow muffler, time cut, see if that makes a difference, and then the next mod will be opening the venturi on the carb. So it'll be staged right through, and it will give everyone, whether you're a novice, a pro builder, I mean, all of this information to me is very valuable, because you kind of can gauge, well, people can look at it and say, well, how far do I want to go? You know, it looks to me like just a gasket delete and a muffler mod, maybe all I need for a good work saw. You know, why port it? The cylinder seems to work well. You know, people can make those decisions. Or if you have the capability to grind, well, go the full hog and port. And what I would like to do after this series of the 361 standard 47mm bore is done, what I would like to do then is to compare that build versus the big bore, and carry the big bore even further, because the big bore that I built right now has a stock carb on it, no carb work, single port muffler mod. So if this sees an improvement with the dual port muffler opening the venturi, I 100% guarantee that the big bore, being a larger air pump, essentially wants to flow more, but it's limited due to the smaller carb and the single port muffler. So we would swap parts. We will put on the dual port on the big bore, put on the stock carb with the open venturi on the big bore, see if it makes a difference, do all time cuts for everything. Then what we will do is we will swap shafts on the carbs. This is your stock 361 here. Come on, focus. No focusing. Come on, guys. Yeah. Right, so 361 on the left, 440 on your right, massive difference, right? So we'll swap shafts, swap the snorkel piece on the top, and we'll have to figure out what we do with the impulse, whether we use a 660 impulse line and just use this, or whether we change this and drill out that little hole there. That coincides with your impulse on the 360, which comes through the intake
manifold. So you have to drill that out if you don't want to use this impulse. But if you use this, you've got to bend a new throttle cable, a new throttle rod to get around this, to clearance it. So, you know, pros and cons to both, I guess, but we will then see if the opening the carb even bigger helps the big bore. And we're gonna open the intake. A lot of people, when you're trying for max flow, open. This is the intake. Just before air comes through the air filter through this into your carb, which sits here on the back. So to get a straight shot in instead of air funneling vertically down and across, open this out. So we're gonna do that. So yeah, it'll be fun. I don't think there's anything else. I don't think there's anything else, guys. We'll probably test filters as well. I mean, to be honest with you, most work saws you're going to use a fleece filter to filter out the fines better. But these are the filters that come in the Pharmatech kits, which essentially are just the spun plastic stuff. It flows well, but it doesn't take out your fines. So these are like winter filters, I believe, which of course in Barbados we have none of. We do not suffer from the cold. So yeah, but we might put this on and see if it improves flow, just for some test cuts. But in a working environment, we'll use the fleece. Yeah, so that's it, guys. This is part one, I guess. What I think I'm going to do, this is kind of just an overview of what we plan to do. We took the stock time in numbers. What I'm going to do is we're going to come back. I'm going to build this saw, get it finished, ready to run, and do the first startup, and then we'll go from there in through the modification series. All right, thanks a lot, guys. Bye.